So I'll go ahead and kick it off here. I'm sure other people will roll in as we go, but I'll go ahead and kick it off with an introduction. My name is Jaron Sanderson. I'm the VP of Manufacturing or of Sales here at TriStar AI. A little bit about TriStar AI. We are an MIT-born startup. We've been around for 4 years. We began as a research project at MIT's Industrial Technologies Lab. Our group of founders we're working together as a team. Our CEO's father had a plastics manufacturing plant, and they did a project where they put cameras in his factory. It was a plastic films plant. They were able to use low-cost, off-the-shelf cameras and get really successful results. Looking at a lot of features that traditional systems were unable to catch. So after they finished their PhDs there at MIT, they started TriStar AI, and we've been going strong ever since, really trying to bring the most cutting-edge AI technology to manufacturing. In this webinar, kind of the format is going to be, I'm going to go through, just a brief introduction to AI and kind of where current state and where it is in manufacturing. Then go through kind of the stages that we like to do deployments in AI to really step by step, incrementally harness the gains that are now possible with AI, and specifically looking at medical device manufacturing. So with that said, I'll kind of jump in. So as we know, in the last 3 to 5 years, there really has been a revolution in AI. AI has moved from something that was kind of a novelty to something that really is a necessity, not just in manufacturing, but in all aspects of business. All of us, chatbots like ChatGPT, Copilots are everywhere. We see, media being created, kind of constantly with AI, and it looks good. It's pretty impressive, and it's really become ubiquitous. Manufacturing, on the other hand, it's somewhat of a struggle to see that value, and because the field is so broad, it's often hard to tackle kind of where to start and how to realize value from manufacturing. And kind of the early results over, the last 5 years or so, we've seen some really good results, but results have been uneven. So I'm just going to go through some numbers on that. From smart manufacturing, manufacturers, specifically in med device, have seen sometimes 20% production and output, 24% employee productivity increases, and then unlocked around 15% of capacity. So these are, huge impacts. 15% of capacity can seriously impact the bottom line of the entire business, and really allow growth at a reasonable investment. This is kind of growth that would normally cost millions and millions of dollars of investment. And AI is really, if it's properly leveraged, is able to do that at a much lower cost. 95% of med device manufacturers report that they are either actively using AI or plan to start using AI. And that's balanced between 50% quality use cases and 50% operations use cases. But here's where that unevenness comes in. Of large transformations involving AI, 70% of those fell, or the results are not as what were expected. So next, we're going to kind of look at what are those failure modes. What causes AI to fail when it's deployed in manufacturing? Probably number one killer is great demos, POCs on a single cell or line that may accomplish a specific task, but don't really scale well across the manufacturing organization. So kind of death by pilot is something that's often seen. And I think this is probably the biggest one, is these deployments fell mostly because of change management. The technology is very powerful, but the fact is, if operators aren't adequately trained, or there's not clear next steps, or your processes don't embed the technology, it's just not going to get utilized. It's going to sit on a dashboard somewhere, so you're not going to see real value from it. Next is, and this goes along with changes, there's data plus integration failures, or just a lack to plan ahead to make those failures. So at the pilot stage, they prove it out, but you haven't really thought forward, worked with your IT departments, your OT people, to make sure it's going to be able to scale within your organization's policies. And then once again, with the data and integration gaps, these detections or these insights aren't actually driving action in the real world. And then, of course, in med device, governance and validation is huge here. It's a regulated environment, so we need to make sure early on we're considering, that we're checking all those boxes in terms of audit trails, in terms of versioning, and in terms of rollbacks. So that's something, at the very beginning, we want to make sure we have on our radar. And then the final one here, and of course, this is huge too, is ROI, and clarity and ROI. So that means from early on, you want to be making sure that you are collecting all the data you're going to need. And even before you dive into a POC, you want to make sure that, the technology is cool and it, maybe kind of a shiny object, but you want to make sure that you're going to deliver value, that when you take this POC to expand, that you're able to show management that this delivers, real value, that you're reducing scrap, that your complaints are down. So really having a data to back up a before and after state is super important at the POC stage as you begin to kind of scale out and expand a program. So now that's kind of what we typically see as faults or impediments to fully scaling AI. So now we're going to talk a little bit about what works and what we've seen that works. So we like to launch a program kind of incrementally. A lot of these large programs fail because they're just aiming too big. So they fail. One, it's difficult to scale the technology initially, or it's very difficult to get buy-in. And this really goes back to change management, right? If you scale incrementally, start small, get buy-in from, and this goes from operators on the floor all the way to management, right? So if you start small, make sure you're managing training for operators on the floor, and show success in those first early pilots. Then you can take those to management. You check the boxes in terms of proving out your ROI, and you can get buy-in both on the floor, but all the way up to management. And that buy-in and managing that change and acceptance of the technology is super important. So we like to stage the journey. So that's early on, we're doing defect detection, we're doing alerts. Then our next stage is what we call a co-pilot. That's where the AI is not only seeing a defect, but also giving advice to an operator on how to fix the defect. This uses kind of manuals and troubleshooting guides. We'll dive a little deeper in a bit. Then the next stage is doing integrations. So this is integrations into PLCs, into MES systems, where we're running kickoffs, taking data from and pushing data back to your SCADA systems. And then the final kind of stage is what we call agentic AI. And that's where AI, we're not just seeing defects, we're interacting with operators, giving advice, but we're also making decisions in terms of machine changes directly. And that's kind of the final stage where, humans are there as a check, on the AI making machine decisions, but in real time, the AI is actually making those decisions. And as I kind of mentioned, what works is starting small and make sure early on that you are building systems that scale, that are going to work when deployed in your IT and OT environments. That you're checking all the regulatory and validation boxes. So start small, but from early on, build the structure to scale. Otherwise, you'll have a 6-month pilot, but then you'll spend the next year just checking all those boxes that you could have easily checked before the project started. Or not necessarily easily checked, but you could have checked before the project started. And as I mentioned, this journey is initially you're giving advice on what an operator can do. Then the next stage is kind of integration. So, kind of follow that stage rollout. And then, as I said before, ROI, showing impact, is incredibly important here. So we want to make sure we're gathering the data, we have the ability to gather the data, and that we can easily show our quality impact and also our throughput and our efficiency gains that the system is bringing. We may know that it's having an impact on quality, but we need to be able to prove it, and we need data to do that. So we need to make sure we're putting those data structures in place as we build a pilot and launch a system. So takeaway here is technology is awesome. There's no doubt about that. But really, success of a program really hinges on change management. And that's from the bottom up, from operators on the floor to their supervisors, to your quality team and the quality supervisors, all the way up to upper management. We need to get buy-in for these systems to have a real and lasting impact throughout the entire organization. And by starting small, making sure we're showing ROI, getting engagement from operators, we can start small doing that. And then it makes the scaling and expanding these systems much more acceptable as we move forward. And we also learn lessons in these pilots, right? So that when we do scale out, we can take those lessons we've learned and deploy them across the manufacturing floor. So stages of adoption, I kind of went into this earlier. We'll kind of dive deep into each one of these. So standalone defect detection with basic alerts to operators, whether that's stack lights or HMIs on the floor. Then the operator co-pilot, that's where the AI is giving an operator recommendations about how to troubleshoot a problem. Integration, this is when we are integrating with your PLCs, MES, and other systems to make basic pass-fail decisions. For instance, with a kickoff or some kind of tagging system, depending on the application and manufacturing environment, it's going to look a little bit different. And also how just your technology stack is structured. And then finally, the last stage would be agentic AI, where AI is making decisions directly and directly communicating and making machine changes or process changes to get into those workflows. So standalone systems. So this is kind of your classic computer vision doing defect detection for quality control. So initial deployments, we'll use stack lights. We'll use an HMI on the floor to alert operators that there's some type of defect and identify what that defect is and have the operator check it out. So critical components to success in this stage is going to be the actual AI models themselves. AI in the vision space is very powerful, and in the last 5 years, it's advanced, incredibly. Traditional computer vision was great for certain tasks, and I'll dive into that a little bit in the next slides. But the power of AI and visual inspection, it's pretty amazing what we're capable of now. So robust models and deep powerful technology is what's available and is what is going to separate AI from your traditional computer vision systems. And then once again, I'm going to mention this over and over, change management. And here we're talking about operator training and support. And we're talking about integrating with processes so that the technology itself becomes part of the process. And that operators know how to use it. And what we find is that operators are our biggest advocates. They really love it, because it's cool. They're using the most cutting edge tech every day in their work. So we get a lot of great engagement from operators. So stepping back to the foundation, which is computer vision and doing defect detection. As I mentioned, technology has rapidly advanced in the last 5 to 10 years. Traditional systems want to see a Coke bottle and they want to see millions of those Coke bottles presented exactly in the same position and the same lighting. And really what they're doing is anomaly detection. Now that's drastically different than what's now possible with AI, computer vision, and defect detection. So here we see a conveyor. The AI is powerful enough to look, the product here is never positioned exactly the same. There's multiple lines on a single conveyor. So what the AI is able to do is look at these products and not do anomaly detection, but actually see and recognize a defect in much the same way that you or I would. Of course, the difference is the AI and computer vision is able to look at 100% of these products, running at very high line speeds, 24/7 without blinking. So this new AI computer vision technology is just incredibly powerful, and if built and structured correctly, a lot of traditional systems have huge problems if there's any type of lighting change, if there's any environmental changes, and all of us in manufacturing know that this happens. A light bulb goes out, which may change the reflectivity of a product, or may change just how it appears. So these newer models are able to actually deal with those without throwing false positives, without just creating more work for the people on your floor. Excuse me. This is a technology we call human action tracking. So here in this use case, the operator is putting bins into a box. I think he's stacking eight stacks, putting those into a box, and then the operator puts eight bags of lids in the box. So the issue here was that if an operator forgot to put a bag of lids in a box, the customer or the customer's customer would receive a truckload of the material, find one box with only 7 lids, and return the entire truck of bins here. And what that resulted in is that our customer would have to open every one of those boxes and have workers count those bags just to make sure there were 8 bags as there were supposed to be. So what this technology does is it's tracking the operator's actions and confirming that they are following every step in their process. You see, you just put a label on the box. So it tracks that, confirms that step is done, counts the number of stacks of pictures that the operator puts in the box, and then confirms that all of that is done and that it's done correctly. Also tracks the operator as he tapes up the box and then puts it on a pallet. And what's critical here is that it doesn't just track the operator doing this. It will give the operator immediate notification if they make a mistake, so that they can immediately go and correct that mistake rather than pushing it further down the line. So this is a packaging application, but this technology also applies to any type of operator process, which includes assemblies, packaging, machine maintenance. So stage 1, defect detection, and basic human action tracking. This is kind of what the ROI we see. And this is with our typical model is a SaaS or software as a service model. There's not a huge upfront investment. So we're typically seeing, positive ROI year one, and often, within the first couple of months, we're going positive in terms of ROI. And it depends on the line. This is for one line. And it's obviously going to vary, pretty drastically based on the line and what you're producing and the value of that. But we typically can see year one ROI of, 150 to 100,000 is not unusual for us at all. And then, of course, over time, that just increases. So jumping into stage 2 here. This is where we would launch what we call our operator copilot. So this is similar to, a ChatGPT or a Copilot, but it's actually made and built for operators on the floor. And these are local deployments. So the AI will understand, not a general. Well, the AI can't answer general questions, but what's really critical about this is that these are line-specific, process-specific, your business-specific intelligence that's deployed. So the AI will learn and be familiar with this specific process, with troubleshooting these specific machines. So the AI actually ingests any kind of machine manuals, any process documentation, any troubleshooting guides. The AI is able to ingest, take in all that data, and then give real-time recommendations to operators when a defect occurs or there's a problem with the machine. And this really empowers faster action and quicker resolution of quality issues, which ultimately can drive quite a bit of ROI if an operator is able to solve a problem independently in 3 minutes, as opposed to tracking down a supervisor and that taking 30 minutes, an hour before a supervisor can resolve the problem. And especially those less experienced operators working at 2 a.m. on a Saturday who may not know what to do because maybe they've only been with the company a couple of months. It really empowers them with the full knowledge, data of the entire organization. So operators, like I said, they love the technology because they feel like it makes them do a better job more efficiently with less effort. So critical components again here are going to be robust models. We call these RAG models, or retrieval augmented generation models. So this is relatively new technology. It's been 3 to 5 years, but having the skill set, having those experts, or working with someone who has experts to really architect the system where it's going to work across the organization, but where it's also going to be able to work and provide data for individual cells, individual lines, and questions for those specific lines and those specific processes in real time. It is quite a complex endeavor. So you really want to make sure you're architecting it ahead of time correctly, and that you have robust models to back that up. And then, of course, continuous improvement with feedback loops in the system kind of built in. And then again, change management. We want to make sure our operators know how to use the tool, that they're trained and empowered to use the tool. We also, incentive structures and gamification can be 2 great ways for operators on the floor to do change management. And that's something we like to work with customers and talk about early on is we're going to do the work in terms of changing processes, documentation, but, are there incentives that we can offer? Is this a place where gamification may be able to help? And by gamification, I mean, with the human action tracking technology, it enables you to reward operators for quality and also for efficiency because you actually have the data to do that effectively. And then gamification. Typically, we see this in a leaderboard. Some customers will have a leaderboard for quality. They'll also have a leaderboard for efficiency. And then maybe at the end of every week, the top 3 operators, get a gift card or something like that can really be effective in driving engagement, and then also giving employees rewards and sort of incentivizing adoption. So this is the Copilot. So this is a Wicketing, it's a packaging use case. And we're just going to pretend like the operator just had a defect where he's got an issue. So he writes into the AI, the bags aren't going on pins. What do I do? So the AI takes this question, processes the questions, then goes back to all of your data, to your data stores, your troubleshooting guides, your manuals, and then the AI comes back with an ordered list of actions that the operator can take to fix the problem. So check pin alignment, then it's going to give citations. The operator can click on those citations if they want to go to the manual or the troubleshooting guide to get documentation for how to do that. Or more often than not, they're able to just use the AI's output to make the changes. And then, of course, what's so cool is the AI will see the operator's actions and is able to create a feedback loop and learn from what the operator did. So if the AI sees that for this defect, adjusting the air pressure is working more often than not on this particular line, the AI, when this issue occurs on this specific line, will know to suggest air pressure first as opposed to making it the third suggestion. And then here's just an example of those leaderboards, whether it's a quality leaderboard, efficiency leaderboard, customers can really get creative with kind of how they do this and, try to make it fun and engaging for operators. So stage 2 ROI, typically there's a little bit larger investment, but you're, also seeing within year 1, you're seeing, significant ROI from those investments. And of course, this is making sure you're doing the architecture correctly and doing change management correctly, as well as, having the technology. So stage 3 here is what we call integration. And this is where we are tying in to PLCs, tying into MES systems. This can vary, pretty greatly depending on a customer's OT and IT architecture, as well as just the level of technology they have on the floor. We have systems where we deploy where customers don't even have Ethernet on the floor anywhere, and we're able to use things like Skylink to give them connectivity. So we can go in a plant that may have 80s or 90s technology, and we can kind of leapfrog to give them, the very most cutting edge technology on their floor, even though they might not have the infrastructure. So you can leapfrog much in the same way that, some countries are leapfrogging, traditional telephone lines. You're able to leapfrog, straight to the cell phone. So that's something kind of really cool about the technology. Having old technology or not having a robust IT infrastructure isn't necessarily an inhibitor. We can still see value from deploying these systems. So like I said, those can vary, drastically how we're integrating. Basic PLC integration is very standard. Integrating to any kind of kickoff systems is all pretty standard. So critical here. This is where we get into that, kind of IT, OT side of things. All our processing is done on the edge locally, and all data lives on the edge locally. Now, I'm sure you guys know, is incredibly important in the medical device environment, but it's also important because these models are powerful, but they're also IT intensive in terms of it takes a lot of GPU to run them in real time. And, especially with kickoffs, you need to be able to pull an image or video and process it in milliseconds. So all of our processing there is done on the edge for speed. And then second critical, especially in medical device, is going to be an AI sovereign cloud for security and compliance. So that this is basically just a separate network from the rest of your IT and OT for security purposes, where your data is going to live on-prem, where no one else can access it. So here's an example where we're integrated with the customer's kickoff here, looking at shorts, looking at Flash, doing all that in real time. So typically from stage 3 rollout, we'll start to see, another incremental jump in your ROI. Not uncommon for those kind of payouts first year to be, $500,000. So really significant gains. And where we're seeing those gains is kind of across the board. We're seeing those gains in quality and complaint reduction, return reduction. We typically see scrap reduction. So we're pulling and improving and efficiency gains. So that means you're able to run more product, which can increase the amount of money you're able to make there. So these systems push gains in a lot of different categories. And like I said, documenting those categories, making sure you're tracking them is super critical to expand these systems, show management, show finance that this system and this technology is working for us and provides a lot of value. So that's something we want to focus on very early. Stage 4 is what we call agentic AI. This is where we've got defect detection on lines. We've got our Copilot going. We're helping operators. We've done the PLC, MES integrations. So the next stage is working with you guys and your process team to allow the AI to make decisions in real time. So this is where we're telling an extruder to increase colorant or increase heat or increase a mold time, where the AI is actually making those decisions on the fly, seeing a defect and then immediately responding it to correct it. So, and as you can imagine, that an AI can do this much more quickly than a human can. So you can see some real efficiency gains, scrap reduction once again. So critical components here, especially in medical devices, is making sure we have a human override and making sure we have an audit trail and making sure that the AI in the system is explainable, that we have model versions, inputs, outputs, that we're documenting, doing all the correct documentation to be compliant here. So here's an example. So this is a packaging use case. So we're looking at gussets here. We're looking at perforations and sill bars. We're looking at alignment of the material. So the AI is actually able to look and understand all these features, able to pull in machine data to understand what is happening with the machine, which is causing these features. And then the AI is actually able to make incremental adjustments to machine parameters to correct for quality errors. And then as it makes an adjustment, it's continuously learning how adjustments are affecting the product. And really what's so cool about this AI is we take visual data, we take machine data, pretty much any kind of sensor data or machine data that you can gather that's useful. The AI is able to ingest it, understand it, make determinations and process determinations in real time, in a way that no human possibly could, just because the amount of data is so vast. This is another example of the human action tracking technology. And this is an assembly type application. So the AI is once again tracking the operator's actions, tracking that they're doing every step in the assembly, every step in the process, and then of course giving them real-time notification if they make a mistake. So it can kind of double as an educational tool, as a training tool. And here, once we get to the agentic stage, in some deployments, the AI can actually make process changes. If you're running an assembly line type application, the AI is able to make suggestions for moving parts of that assembly to different cells. If you're running, so in some applications, we'll have an assembly line type application where there's a time movement of the product from one cell to the next. And say the customer had a 45-second cycle time per cell. What the AI can do is look at every cell as it's happening in real time. And rather than waiting for 45 seconds to move that line, we can do it as soon as every operator is done with their task. So in those type applications, cycle times of 45 seconds can sometimes be pushed down to 35 to 40 seconds, which is, like a 20 to 30% jump in productivity just by being able to increase that cycle time. So pretty powerful stuff you can do here with the technology. This is what we call our red to green. So this is just a operator product view histogram here. You can see what we typically see is that defect runs will go for very long periods in manufacturing often. And that's really what we're able to drastically produce is you don't have these hour, 2 hour, 3 hour runs where you're running defective product. Maybe you do catch it, but then you've lost 3 hours of production and you're scrapping all of that product. So what we're able to do is see those defects, notify operators immediately, make immediate changes so we can decrease that time that defects being run. We can just decrease that drastically. So we like to call it red to green. And we typically see this change and this shift happens in the first month or two of deployment. So that by month 4, you've kind of stabilized and you're running a whole lot less defective product than you previously were. Also, so this is a role application. In the specific run, the AI detects, okay, there are this many defects in this role, and can make a determination about whether that role itself, because it has so many defects, whether it's salvageable. For instance, this role is not salvageable. This role, there's only defects at the tail end of the role. So that role can be, this tail end scrap can be cut off and the role can be salvaged. So any kind of, what would be kind of complex judgments, the AI is actually able to make those on the fly in real time very quickly. So this is kind of the typical what I was mentioning before. This is the first 5 months of deployment. This specific defect, they were seeing 14,000 of these a month, and by the end of month 5, they're down to 2,000. So pretty drastic reductions in the number of defects, which means drastic reductions in the scrap you're producing, and real impact. And this isn't even getting to, quality escapes or, complaints or returns or recalls from customers, but just on the scrap and efficiencies side, there's so much value to unlock here. So first year stage 4 ROI, we can see 500,000 plus is not at all unusual in these systems. So, you can capture huge value, at a relatively low cost of entry here for this technology. Now let me see. Well, I want to be cognizant of everyone's time here. We're getting to 45 minutes. I do have some use cases I was going to go over, but I think I'm just going to jump ahead. In summary, this AI technology is incredibly powerful stuff. The potential, is vast. I think everyone knows that. So how do we get there? We, as I mentioned, we like to take a staged approach. Start small, but when you start small, check your boxes, build to scale. Make sure you're checking your validation boxes. Make sure you're checking your IT, OT, security boxes. Make sure you're looking at POCs and use cases that will deliver real value and make sure that you're able to document that value. And that's really what's going to, and of course, sorry, I forgot change management. Super high on the priorities list. You want to make sure operators are trained and using the tools. And you want to make sure, every step along the way, you're getting buy-in from management, they're understanding and able to see the value of the technology. So next up, we will move into question and answer. I'd love to hear if you guys have any questions. I think to do this, we can do, if anybody just wants to raise their hand if they have any questions, and I'll do my best to answer them. Yeah, John Henry. I think you're muted, John.
Hello? Okay.
Yes, we can hear you now, John.
Great. John Henry, changeover.com. I heard you say something about popping up checklists. Now, maybe you covered this because I came in a few minutes late, but we work with a system that identifies when downtime happens, like when a machine stops, and we identify the reason. But you gave me an idea. If we identify the reason, can we have your system pop up like a checklist or a fishbone chart or something? The cartoner stopped because of the timing screw, and then pop up on the screen. These are, the 5 most common solutions.
Yeah, absolutely. Yeah, so we can do an ordered checklist of troubleshooting tasks. With that ordered checklist of troubleshooting, we can provide documentation so that they can go back and see if there's a manual, a specific manual that has further details on how to troubleshoot this specific problem. Kind of provide that full documentation, build in links so that an operator can just click on a link to pull up the manual. And the location of where that information is in the manual, as well as the models are very flexible in terms of the level of detail that they provide, as far as and can be super technical in terms of the instructions that they actually give. The other cool thing is they can be very line specific. So say you have 20 lines and these systems, this AI deployed across all 20 lines. Each individual line will have its own instance of the AI. So the AI will learn as a group, but it will also learn line-specific details. So say you have a different machine at the end of lines 1 through 8, or it just runs differently somehow, or say these machines are updated, these machines aren't. The AI has the ability to actually learn each individual line and specific information about that specific line, so that it's not just giving a generalized troubleshooting, it's giving line-specific, machine-specific instructions for how to troubleshoot a problem.
Thank you.
Of course. Miguel? I think you're on mute, Miguel.
Yes, Adam. In regards of the regulated industry, what would be the validation approach, for example, vision systems that are using AI technology? Is going to be the same approach at the conventional vision systems? How is going to be the backup and restoration of this software is managed? Do you have more detail how the industry is handling that?
Yeah. So this is, super critical piece of the picture in medical device, and super critical to make sure before we launch a POC that we are typically, most of the companies we work with have internal validation teams. So make sure we're working with, these are pretty complex systems involving a lot of different departments, right? So we want to work with the IT team, we want to work with the OT team, we want to work with the validation team, as well as the quality team, obviously. But we want to make sure early on we're bringing in all those key stakeholders, and that as we design the system, we're getting checks from each one of those stakeholders, and we design the system in such a way where we're going to be able to meet your organization's kind of structure, architectural, IT, OT, validation needs. And then we're also not only going to design the system to work within your architecture, but we're going to have a very planned deployment of that system to making sure. I'm not a validation expert, so I'm not super familiar with all the steps. I believe there's an install validation and operations validation, and then a performance validation. So we want to make sure we're planning for those ahead of time, that we're not installing cameras and then trying to to run backwards and do that after the fact. We want to make sure we're planning that and those steps and then those processes as part of our deployments, and that we're doing all the correct documentation, that we have all the correct rollback sort of technology in place. Because a lot of times if you build a system where you can, it's much easier to build a system that you can roll back ahead of time than it is to try to fix one that wasn't built correctly in the first place. So you want to make, whether you're working with us or anyone, you want to make sure that they kind of understand the space and kind of what's needed to be successful in this space.
So basically, in order to restore an application, let's say that is running with an LLM or a brain, so you have to be able to run that LLM locally in order to restore it. So we have to create a restoration process for the LLM, the model, the resources, any data set that are using all that in a package.
Correct. Yeah. So, and we're typically running locally on-prem, but we are typically running these on our own dedicated servers, so that we're on a separate, so that we're separate from your IT and OT networks. We'll have defined interfaces with you guys' networks, but we typically we call it the AI Sovereign Cloud, where we are running separately from you guys' IT and OT networks with only defined connections where data flows. If that makes sense.
Yeah, and in the other question, in agentic models, have you find failure modes like hallucination? How do you handle those cases?
Yes, and that's been a concern, I think, for many of these larger projects, and it's something we want to look at and talk to early on, because it is a concern. You typically see larger issues with hallucinations, and so the types of LLM. Okay, yeah, Adam. This is Adam. He's
Hi, my name's Adam. I'm principal engineer at TriStar AI. To give you a concise answer, we check for conversions of several different models on essentially what is documentation for the process that's in question. And if we see conversions across different models using RAG to identify if the process is correctly, if the problem is correctly identified through convergence, then we accept the response. Otherwise, we do not provide the response to the operators.
So it is an approach to once the model is in production or the application is running in production and is validated, to have like a change process in the case that it deviates from the validated behavior, so you can reteach the model without redeploying or validating the whole application.
We are, in general, we are not retraining the LLMs. We have identified a set of, for this specific use case, we've identified a set of LLMs that meet the performance and meet the correct performance criteria, so they respond quickly enough and provide meaningful responses back. We use grounding heavily. We structure the documentation and any other processes that you have in a way, together with guardrails, in a way that we can get reliable results repeatedly.
Okay, thank you.
Great question, and Adam, thank you for jumping in there and rescuing me. I'm more of a generalist, but Adam here, he really knows his stuff. Any other questions, guys? Okay, I don't think we have any more questions. Well, thank you. It looks like we'll give you guys a little bit of your time. Thank you all so much for joining us here. I hope this was valuable for everyone.